For decades, we've believed that the universe is expanding faster and faster, driven by a mysterious force called dark energy. But what if that's not true anymore? What if the universe is actually slowing down? In 1998, scientists made a discovery that shook the world of cosmology. The universe wasn't just expanding, it was accelerating. This led to one of the greatest scientific mysteries of our time: dark energy. An invisible force, undetectable by any telescope, yet powerful enough to push galaxies apart at increasing speed. We thought we had the answers, but a new study, quietly released by a team of astronomers in South Korea, suggests something astonishing. The expansion of the universe may be decelerating, and that changes everything. Could this mean that dark energy is not constant, or even disappearing? If so, it flips decades of assumptions upside down. It would mean that gravity might be winning the cosmic tug-of-war once again. That the universe, instead of rushing endlessly outward, might someday stop or collapse. Tonight, we dive deep into this shocking revelation, the strange clues hidden in exploding stars, the controversial data that challenges everything we thought we knew, and the haunting question it raises. Are we watching the beginning of the end of the universe? Before we can understand why the idea of a slowing universe is so shocking, we need to go back to the very beginning. Nearly 14 billion years ago, our universe was born in a cataclysmic event known as the Big Bang. Everything, space, time, matter, burst forth from a single, unimaginably dense point. And ever since that moment, the universe has been expanding. Imagine the universe like a balloon. Every moment, the balloon grows bigger. Galaxies aren't flying through space. Space itself is stretching, carrying them apart. For most of the 20th century, scientists believed this expansion was slowing down due to gravity, the pull of all the matter in the cosmos gradually reining it in. But in the late 1990s, two independent teams of astronomers made a discovery that flipped everything upside down. By observing distant exploding stars, type 1a supernovae, they realized the universe wasn't slowing, it was speeding up. This was unexpected. Some unseen force, was pushing the universe outward with increasing energy. That mysterious force was named dark energy. And it wasn't just a small part of the universe. Calculations showed that dark energy made up a staggering 70% of the cosmos. It became the dominant factor in our understanding of how the universe behaves, a silent architect of our cosmic destiny. Since then, nearly every model of the universe has assumed that dark energy is constant, an unchanging force that keeps accelerating the universe forever. That's why this new discovery, that expansion may be slowing, is not just a minor adjustment. It's a potential earthquake in cosmology, a sign that our balloon universe may no longer be inflating as we thought. For over 2 decades, scientists have relied on a specific kind of stellar explosion, type Ia supernovae, as cosmic measuring sticks. These supernovae are incredibly useful because they act like standard candles. No matter where they are in the universe, they explode with almost the same brightness. By comparing their true brightness to how dim they appear from Earth, astronomers can calculate their distance, and from there, the rate of expansion of the universe. This method helped reveal the accelerating universe in the 1990s, but now it's being revisited and challenged. In a recent study, a team from Yonsei University in South Korea, in collaboration with the DESI project, looked at more than 1,500 type Ia supernovae. But this time, they added a twist. They factored in something that had been overlooked, the age of the stars that created those supernovae. Turns out, not all type Ia supernovae are born equal. Some are created from younger stars, others from older ones, and that affects how bright they really are. If you ignore this difference, your calculations about distance and expansion might be skewed. Once they adjusted for this age bias, something strange happened. The data no longer showed a clear acceleration in the expansion of the universe. In fact, it suggested the opposite, a possible deceleration. This doesn't just tweak the numbers, it shakes the very foundation of modern cosmology. Because if the universe is no longer accelerating, then dark energy might not be what we thought it was, or might be changing, weakening, or even disappearing. The researchers propose an alternative model, one where the universe expanded rapidly after the Big Bang, then gradually slowed down, just as we once believed before dark energy was introduced. But this time, it's based on newer, more refined data. Of course, this finding isn't conclusive yet. The scientific community is still debating it, but if it holds up, it could rewrite the story of the cosmos. For over 25 years, dark energy has been treated as a constant, an invisible force pushing the universe to expand faster and faster. No one knows what it is. We can't see it, touch it, or detect it directly, but its effects were undeniable, until now. If this new study is right, and the expansion of the universe is actually slowing down, then dark energy may not be constant at all. It could be weakening, or worse, disappearing. And if dark energy fades, what happens next? One possibility is that gravity, the force that holds everything together, will begin to dominate again. For billions of years, gravity and dark energy have been locked in a cosmic tug-of-war. But if dark energy weakens, gravity wins. That would mean the universe will stop expanding. Eventually, it could begin to contract. Galaxies that are drifting apart now might start to inch closer. Stars would clump together. Black holes could merge. In the most extreme scenario, this leads to what physicists call the Big Crunch, a reversal of the Big Bang, where the universe collapses in on itself. Others propose a cyclical model, a universe that expands and contracts in an endless loop, a cosmic heartbeat that never truly dies. Of course, these are just theories, but the fact that we're even considering them again shows how much this new data could reshape our understanding of everything. And perhaps the most unsettling thought? If dark energy isn't constant, then the fate of the universe is no longer predictable. As mind-blowing as this discovery sounds, we have to be clear. It's not yet confirmed. The study has sparked fierce debate in the scientific community. Some researchers argue that the data adjustment, accounting for stellar age, is too uncertain. Others believe the new findings are compelling and deserve further investigation. This is how science works. Big ideas are tested, challenged, and pushed to their limits before they are accepted. And this one is no exception. In the next few years, we'll have a better chance to test it. New telescopes and surveys, especially from the Vera C. Rubin Observatory, set to come online soon, will provide far more detailed and unbiased data about distant supernovae. If these results are confirmed, they may force cosmologists to rebuild the standard model of the universe from the ground up. If not, we'll better understand the limits of our measurements and maybe refine the tools we've relied on for decades. Either way, this research is already valuable. It's forcing us to question what we thought we knew, and that's how discovery begins. The universe may still be accelerating, or it may be slowing. But what matters most is that we keep looking up, keep asking questions, and stay ready for the next cosmic surprise. So where does this leave us? After decades of believing the universe is racing outward faster and faster, we're suddenly faced with the possibility that it might be slowing down, that what we thought was the engine of cosmic expansion, dark energy, might not be eternal, might not be stable, might not even exist the way we imagined. If this is true, we'll need to rethink everything, from how the universe began to how it might end. And yet, maybe that's the most exciting part, because every time we think we've figured out the universe, it surprises us, it humbles us, It reminds us that we are still at the very beginning of understanding this vast, mysterious cosmos. One flicker in a distant supernova. One data point reanalyzed, and suddenly, the future of the universe looks different. We don't know for sure if dark energy is fading or if the expansion is truly slowing down. But one thing is certain: the story of the universe is far from over. And the more we look up, the more we realize how little we truly know.